Hello guys, I'm coming from the future. I recorded this video before, but in this video we will talk about references and what is the difference between references and pointers. Enjoy the video, and if you like such contents, don't forget to like and subscribe to the channel to not miss the next videos. Good luck. Now it's a good time to talk about references. Reference is a powerful feature in C++ that can enable us to work with the memory more efficiently and more safely. A reference is an alias for an existing variable. Unlike pointers, references always refer to a valid object and cannot be null or uninitialized. Let's talk about an example to understand the reference more clearly. In this example, we have the integer of the x, which we initialize it with the value, for example 10. Then we define the reference. We have the int with the and sign, which is equal to the variable of the x. So if we assign 20 to the ref, it will also modify the value of the x itself, since it is referring to the x. You can validate it by putting the output of the x into the C. In this case, ref and x, there are two different names, but they are pointing to the exact same memory location. Unlike pointers, references can be called their variables by only calling them directly. You don't need to use any star sign for references. The another key difference between references and pointers: in the reference, they need to be initialized when they are declared. If you create an uninitialized reference during the compile time, you will get an error. In the previous example, if you don't assign x to the reference by just defining the reference itself, you will definitely get an error from the compiler. But why we want to use reference instead of pointers? Well, there are several advantages of the references over the pointers, but these advantages are specific for specific scenarios. References can make the code safer and easier to read because in general they cannot be null and they cannot be uninitialized. And by just having that as a rule, they will avoid the common problem that pointers can have. With pointers, you need to always check the null point exception before using them to avoid the crashes in your program. But with references, you don't have this problem. For example, in this pointer, when we add the null pointer to the pointer, your program gets compiled and you can execute your program. But while you're executing your program, you get the error when you try to access the pointer. In that case, it will crash your program. But with references, you will never need to check for the null values, since they're always for sure refer to the valid value. Like pointers, references are best for the function arguments to avoid copy of the data. So if you want to pass the argument to the function instead of pointers, you can also use references to avoid this unnecessary copy of the data when you're passing the real value to the functions. As an example, you can see the function which accepts the reference as an argument, and by changing the value of this reference, you are basically changing the original value as well. But what are the pitfalls of references? Although they're making your program safer and nicer to read, they have also disadvantages which you need to take care of them. The first disadvantage which we talk about is that references need to be initialized and declared. If you define them, you must assign them immediately. This can be restrictive in case that you don't know what or when to assign those references in your program. The another pitfall is that references cannot be reassigned. References are always referring to the same object and you cannot reassign them to another object. With pointers and pointer arithmetic, you can move the pointers into the different memory addresses, but with references, you don't have this flexibility at your hand because the connection of the reference to the memory address of this variable is permanent. In the references, the dangling references also can happen when you are dealing with the temporary objects. Because reference must always point to the valid object, if the object gets destroyed, reference becomes dangling, and accessing that specific reference causes undefined behavior. In this example, we define the function called getRef. This function has a local variable, and this local variable is integer, which is allocated by 10. But when this local variable gets returned, the reference of it gets also returned. After this returning, the function gets deleted, which means that the local variable of the function also gets deleted. In this case, the reference is dangling, and when you try to access this reference in your main program after the function calls, you get an error of undefined behavior. To avoid this problem, you need to always make sure that your reference points to the long-lived objects instead of temporary objects. When should we use reference? When should we use pointer? We are talking about a lot of points. Let's wrap up the points that we already discussed. If you want to have safer program or easier to read programs, then you need to use references instead of pointers. If you want to pass large objects into the functions as an argument, especially if efficiency is your high priority, you need to use references. Also, in the case of a constant alias for the variables, which would long live in your program and you don't want to change that, then you need to use reference. On the other hand, for the pointers, if you want to have more flexibility, pointers are the tool that you need to use. If you want to use complex data structures like trees, graphs, or linked lists, pointers are your tool to use. Also, in the case that you have a variable which can be reassigned or which is allowed to be null, also pointers are the ones that you want to use, since references cannot be used in those cases. Okay, it's enough for today. In the next episode, we are talking about the virtual memory and paging. Until the next video, good morning, good afternoon, and good evening. Bye.